Hi and Assalamualaikum warahmatullahi wabarakatuh. My name is Amirul Asyraf from Bekeri, and I'm going to present the introductions for our projects. So there has been a rise in market demand for shrimp in the last 2 decades. 80% of the shrimp consumed in the United States was imported in 1998 to satisfy market demand, contributing to a trade deficit of 3.2 billion. This deficit has grown primarily due to a strong domestic economy in the United States, leading to a rise in both sale growth and shrimp demand at home. So there are 3 major limiting procedures in convenient pond system. They are used to produce the bulk of farm-raised shrimp in the United States. That is, first, length of growing seasons, second, land limitation, and third, high water exchange rates. So shrimp have a temperature-based growing season. Therefore, mostly during time of year when the temperature is favorable, pond can only grow shrimps. And for growth, land limitation apply to the fact that pond aquaculture is usually situated near the shore for easy exchange of water with estuaries and other bodies of water. So aquaculture pond influence are categorized by organic biomass, nitrogen, phosphorus suspended solids, biological oxygen demands, BOD, and chemical oxygen demand, COD. So a sequencing batch reactor, SBR, is used to boost the consistency of the water in the shrimp aquaculture. So this procedure uses multiple steps in the same tank to replace multiple tanks in the traditional treatment system. The SBR conduct equalization, aeration, and clarification in a time series in a single reactor basin.
For the problem statement, today shrimp farming has developed rapidly in coastal area. Effluent discharge from shrimp farm with high level of nutrient waste may cause eutrophication in the inland waterways. Therefore, the assessment of water quality inside the stream receiving shrimp farm effluent in coastal areas promotes environmental protection and decision making for the region's sustainable development. Maintaining a good shrimp culture pond is crucial for growing healthy shrimp, achieving satisfactory production, and improving crop efficiency. High yields and profit in fish farming depend entirely on proper management. However, even under good management, a number of technical difficulties may arise during fish farming, with the possibility of a large-scale loss of production. In the table 1, median values for each variable of water quality were determined using combined data from semi-intensive and intensive shrimp farm.
My name is Fitri bin Naim and I will present about the standard shrimp pond wastewater. Water quality is a very crucial in fish and shrimp farming. In any case of a specific aquaculture system use, a balanced level of water quality parameter should be maintained because it is very important to the health and growth of aquatic species. This is a table for the standard quality parameter. For the reserve oxygen, the standard value is more than 4.0 mg per liter. For the temperature, the specific dependent. For the pH, 7.5 to 8.5. For the salinity, for fresh water, less than 0.5 ppt. For the brackish water, 0.5 to 30 ppt. For the salt water, 30 to 40 ppt, and the optimum value is 15 to 25 ppt. For the carbon dioxide, less than 10 ppm. For the ammonia, 0 to 0.5 ppm. For the nitrate, less than 1 ppm. For the hardness, 40 to 400 ppm. For the alkalinity, 50 to 300 ppm. For H2S, 0 ppm. For BOD, less than 50 mg per liter. From the table, we must compare with the characteristic of the shrimp pond wastewater, and the value of the characteristic must in range of a standard value.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhamad Firdaus bin Muhammad Aslam with the metric number DF1800075. Today I want to explain about the method of the shrimp pond treatment, wastewater treatment. The first method that I want to present is the SBR, which is stand for sequencing batch reactor. SBR can remove the unwanted element and then discharge it to the suitable place after being treated. The process of equalization, erosion and clarification can all be achieved using a single batch reactor and can be optimized of the performing of the system by implement 2 or more batch reactor. SBR system promise to reduce more operating costs and plant space. SBR consists of the following process stage that's shown in slide. We start with the fill, react, settle, decant and idle. At fill tank, influent wastewater is added to the tank. At the react tank, the water have been mixing in 3 different tanks, which is aerobic and then anaerobic and back to aerobic. For the settle tank, the sediment will settle at the bottom of the tank. And the last is decant. Decant tank is used to remove the treated effluents. Okay, for the next method is the biological filtration. Biological filtration can remove the inorganic matter from the wastewater and biologically can treat the sewage effluents. The system is quite same with the conventional wastewater treated in Malaysia, but it consists of GSC biofiltration in its system. GSC biofiltration can be used to remove the certain chemical and eliminate contamination. For the last purpose method, which is water recycle system, which the system can use the same water that have been used after being treated. The system is divided into 4 phases, which is settling basin, semi-settling basin, edging canal, and reservoir. Settling basin is used to make the sediment settling on the bottom of the tank, while the semi-settling basin is using to treat the water by the biologically filter, which is use the bacteria as the medium of it. For edging canal, it is make sure that the biofilter to be efficient when treat the water. And for the last phase is reservoir, is the place where the treated water is stored. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Rifdi bin Johari, and I will explain about our recommendation for our studies, which is we select the SBR, which is sequencing batch reactor, as our best treatment for shrimp pond. So effective shrimp aquaculture demands the conservation of water consistency, which is crucial for shrimp production. Inorganic suspended solid ISS, total suspended solid TSS, biochemical oxygen demand BOD, chemical oxygen demand COD, dissolved oxygen DO, and nitrogen are typical water quality issues of shrimp aquaculture. So incorporation of aerobic and anaerobic process into one reactor will reduce the cost of capital through an innovative concept called SBR, which is sequencing batch reactor. SBR is a variation of the activated sludge biological treatment process in a single reactor basin that achieve equalization, aeration and classification at the same time, whereas other traditional systems use a continuous flow process that involve multiple structures and elaborate system from pumping and piping. The SBR successfully separated carbon and nitrogen from the sludge sample of shrimp aquaculture wastewater. During the reactor's aerobic activity, the nitrifying species occupied the system. This was illustrated by the evidence on the reduction of ammonia in wastewater sludge, for example, in our figure 1, in our methodology. During SBR activity, the nitrifying species occupy the system. This was illustrated by the fact that nitrate and nitrite and nitrate concentration decreased significantly during the anaerobic process and reached about 5 mg in our table 5. In both aerobic and anaerobic environments in the SBR, carbon was also successfully removed. In addition, the findings indicate that within 7 days, almost 100% of ammonia, nitrate and nitrite and COD are derived from shrimp wastewater. So the sludge can be dewatered, and at the end of the process, the water will be recycled back into shrimp farming. Use of SBR technology for intensive shrimp processing is an enticing alternative to the different methods commonly used in shrimp aquaculture. That's all for me. Thank you.
Hi, so for the conclusions, wastewater produced due to the rapid growth of this system can cause significant environmental problems, and the disposal of waste can be very difficult and costly. Since the recirculating system of the raceway is a zero water exchange system, nutrients such as nitrogen, phosphorus, and organic carbon will develop in these systems. Techniques such as a batch sequencing reactor (SBR) is used to help eliminate ammonia, nitrate, and organic carbon so that wastewater can be reused. The possibility of salt recovery and reuse of water in the shrimp farm should be examined. The sustainability of the system will boost profit in the aquaculture sector. For the better management, it is suggested that responsible agriculture methods be used to reduce water contamination. The wastewater is discharged into the atmosphere, it is likely to return to you sooner or later in the form of disease. That's all.